Hi guys, welcome to my channel. In this video, I will be covering complete unit 3 in PPS. I will explain each and every topic in detail. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. And guys, I have uploaded complete PPS subject tutorials. I will provide link in description. You can watch from there. Let's get started. First topic is preprocessor in C. Preprocessor is not a part of the compiler, but it is separate step in compilation process. In simple terms, we call preprocessor as text submission tool. Preprocessor is not a part of the compiler, but it is separate step in compilation process. That means whatever the task that we perform before compilation, we call the task as pre-processing task. All preprocessor commands begin with hash symbol. Example, hash include stdio.h. This is diagram of how preprocessor will work. As we know, whatever the program that we write in C, we call this program as source code, and we will save this program by using .c extension. Example, program.c. This is how we save program. Whenever you compile this program by clicking on Alt F9, before compiling program, compiler will check whether any preprocessor commands available in our program or not, and then it will perform pre-processing task. After completion of pre-processing task, our program.c file is converted into program.i file, where this program.i is extensible file. This program.i file is converted to object file by compiler, and then this object file is sent to linker in order to create executable file. So after generating executable file, we can execute our program. Preprocessor directives are classified into 4 types. We can also call these preprocessor directives as preprocessor commands. They are: first one is macros, second one is file inclusion, third one is conditional compilation, and fourth one is other directives. First one is macros. Hash define directive is used to define macro. Whenever you want to define macro, you need to use directive that is hash define. Macros are piece of code in a program that is given some name. Whenever this name is encountered by the compiler, then this compiler will replace this name with value. I will give an example so that you can clearly understand. This is syntax of macro, that is always we need to include hash define directive in order to define macro, and macro name, and this is value. Normally we write program like this: hash include stdio.h, and after that I written void main. Inside void main I written int a equal to 10, where int is data type, a is variable name, and 10 is value. After that I written printf %d comma a. Whenever I write this code, then whatever the value that is present inside this variable a will be generated as output. So my output is 10 because value of a is 10. Same program I written like this: hash include stdio.h, and after that I written hash define a10. Whenever you write like this int a equal to 10, we call a as variable, but whenever you write like this hash define a10, we call this a as macro, and value of this macro is 10. After that I written void main, and inside void main I written printf %d comma a. Here I written %d because this 10 is integer, so I written here %d. So by writing this code, I will get output as 10. Here there is no need of declaring data type. Directly you can write like this: hash define a10, where a is macro and 10 is value. For example, if you want to define float value, then here I written float value as 10.5, and just we need to change format specifier to %f, so that I will get output as 10.5. Next one is undef directive, where undef stands for undefined. For example, whatever the macro that you define, if you want to remove that macro, then you need to use undefined directive. This is example. Here I written hash include stdio.h. After that I written hash define a10. Here I define macro a, and I given value of this macro as 10. After that I written hash undef a. That means whatever the macro that I defined, now I am removing that macro. So here I written hash undefined a. After that I written void main. Inside void main I written printf %d comma a. Whenever I read this code, then I will get output as error, because actually I should get output as 10 because value of this macro is 10. But I removed this macro. Whenever you write undefined a, that means I am removing this macro. So this macro is removed and I will get output as error message. Next one is file inclusion directive. For example, if you want to include any files to our program, then we need to use file inclusion directive. For each and every program, we use file inclusion directives. For example, if you consider this program, here I written hash include stdio.h, where stdio.h is header file. This is file. So whenever you want to include any files to our program, then you need to use file inclusion directive. This is syntax of file inclusion directive, that is we start file inclusion with hash include, and inside angle brackets I written file name, or you can also write like this, hash include double quotations file name. This is an example. Here I written hash include stdio.h. After that I written void main, and inside void main I written printf hello world. Here I took file, that is header file stdio.h, because meaning of printf is present in stdio.h. So I took here hash include stdio.h. This is example of file inclusion directive. And next one is conditional compilation. For example, if you consider conditional statements like if, else, if, how this conditional statement works, in same way this conditional compilation directives also work. That is, if you want to generate output based on the condition, then we need to use conditional compilation directives. These are the 6 types of conditional compilation directives. First one is if defined, and next one is if and if, that means if not defined. Third one is if, fourth one is else, fifth one is elif. Elif stands for else if, and sixth one is endif. This is example program for hash if defined directive. Here I written hash include stdio.h. After that I written hash define a10. That means I am defining macro a, and value of this macro a is 10. After that I written void main, and inside void main I written hash ifdef a. That means hash if define a printf hello. And at last I written endif. We need to write conditional compilation directives inside main function. So that inside main function I written hash if define a. The meaning of this is, if I define macro a, then I need to get output hello. Did I define macro a? Yes, I define macro a here. Hash define a. If I define macro a, then I need to get output hello. So now I will get output as hello. For example, if I do not define this macro a, then I don't get output hello. And definitely at last you need to close conditional compilation directives by using hash endif. So for each and every conditional compilation directives, at last you need to use hash endif. That means we are closing this condition. This is example program for if and if directive, where if and if stands for if not defined. Previous program is for if defined, and this program is for if not defined. That means if I do not define macro, then I need to get output. So here I written hash include stdio.h. After that I written hash define a10. That means I am defining macro a, and value of this macro is 10. After that I written void main. Inside void main I written hash if and if a. That means if I do not define macro a, then I need to get output hello. And we need to close this if and if condition by using hash endif. So at last I written hash endif. Whenever I write this condition, then I will get output as nothing. I do not get any output, because here if I do not define a, then I need to get output hello. But here I already defined a. So then you do not get any output. Condition is if not defined a, then I need to get output. But here I defined a, so I don't get any output. This is example program for hash if, hash elif and hash else directives. This program is same as if, else if and else program. By seeing this example, you can clearly understand. At first I written hash include stdio.h. After that I written hash define a15. That means I am taking macro as a, and value of this macro a is 15. And inside void main I written hash if a less than 10, printf value is less than 10. That means if value of a is less than 10, then I need to get output as value is less than 10. Hash elif a less than 20, that is if value is less than 20, if a value is less than 20, then I need to get output as value is less than 20. Else I need to get output as number not found. As I said before, every conditional compilation directive ends with hash endif. So at last I written hash endif. Whenever I write this code, here I given value of macro a as 15. This 15 is less than 20. So now I will get output as value is less than 20. For example, if I give value as 100, here if I give value of macro a as 100, then I will get output as number not found. First one is other directives. Other directives includes undefined directive and pragma directive. I already explained this undefined directive. Last one is pragma directive. This pragma directive is special directive. For example, if you want to turn on or turn off any special features, then you need to use this pragma directive. This is example hash pragma startup, hash pragma exit, and hash pragma warn, where this startup, exit and warn are special features. Next topic is file handling in C. First, what is file? File is collection of records. For example, if you consider PDF file contains some text information. We call this text information as collection of records, or you can also call this information as collection of related information, because we store only related information in our files, and we store files in hard disk. Hard disk is permanent storage device. This is an example to declare a file. We declare file by using file type along with pointer variable. Here I took pointer variable as A, where star represents pointer variable. Next, types of files. In C language, files are classified into two types. One is text file and another one is binary file. At first, I will explain what is text file. Text file contains alphabets, numbers and special symbols, which are easy to understand by human beings. For example, if you consider MS Word, in MS Word we can write text, so we call it as text file. And in text file we can write numbers, alphabets and as well as some special symbols. And if there is any error in text file, it can be eliminated easily. For example, if I do any spelling mistakes in text file, then it is easy to correct. In text files, all alphabets, numbers and as well as special symbols are treated as characters, and each character occupies 1 byte of memory. If you consider this example, in this total there are 4 numbers. Each number is treated as single character and each character occupies 1 byte of memory. So total there are 1, 2, 3, 4 characters. So it will occupy 4 bytes of memory. For example, this is text file. This text file name is my file, and this file contains total 7 characters. 1, 2, 3, 4, 5, 6, 7. 7 characters. So it will occupy 7 bytes of memory. Next, binary file. Binary file is combination of zeros and ones. It do not contains any special symbols or any alphabets. It contains only zeros and ones. Whereas text file is easily understood by human being, and whereas binary file is easily understood by computer. It is not easy to eliminate errors in binary file. And in binary file, the integer value 1245 will occupy 2 bytes of memory. For example, if you consider in text file each number is treated as single character, so it will occupy 4 bytes of memory. But whereas in binary file, this 1245 is treated as single integer value and it will occupy 2 bytes of memory. For example, if you consider this 1234, this is single value, it will occupy 2 bytes of memory. For example, 2345, it will occupy 2 bytes of memory, and as well as 12455, it will occupy 2 bytes of memory. A binary file always needs a matching software to read or write it. For example, if you consider movies, if you want to watch any movie, then we need VLC player in order to view that movie. And similarly, if you want to access binary files, you need matching software in order to open that binary file. Files are classified into two categories. One is sequential files and next one is random access files. In sequential files, data is arranged in sequence manner. For example, if you consider your rule numbers, data is arranged in sequential manner, like rule number 1, rule number 2, rule number 3, so on. And whereas in random access files, data is not arranged in sequential manner. Data is arranged in random way. For example, rule number 1 and rule number 32 next and rule number 44 next, like that. Next one is file operations. Totally there are 5 major file operations. They are: first one is creation of new file, second one is opening an existing file, third one is reading file, fourth one is writing file, and fifth one is closing file. In order to perform these file operations, you need to know what are various file functions, and as well as you need to know what are various modes of the file. At first, I will explain what are various file functions. In order to open a file, you need to use fopen function, and in order to close a file, you need to use fclose function. By using getc, getw, fscanf and getc, you can read file information. Reading file information means whatever the text that is present inside a file, you can see the text on our output screen. We call it as reading a file. And by using putc, putw, fprintf and fputs, you can add text to our file. Next, various modes of the file. First one is R. R stands for read mode. By using read mode, you can only read that file. You cannot add any text to that file. You can only read that file. Next one is R plus mode. By using R plus mode, you can read and as well as you can write text to a file. And next one is W mode, where W stands for write mode. If you want to remove previous text and if you want to add new text, then you need to use write mode. This write mode will remove previous text and then it will add new text. For example, I want to add CSC. By using write mode, we can remove previous text and then it will add new text to the file. Next one is W plus mode. By using W plus mode, you can read and as well as you can write data to a file. And next one is append mode. Meaning of append is adding data at the end of the file. Already there is some data in my file. I want to add new data, then I need to use append mode. If you consider this example, already some text is present in my file like btech. Now I want to add new text. at the end of the file, then I need to use append mode. By using append mode, you can add data at the end of the file. Now I want to add csc, so I can add csc at the end of the file. Last one is a plus mode. By using a plus mode, you can read and as well as you can append data to a file. All these are various modes for text file. Now let me explain various modes for binary file. It is same as text file. First one is RB mode. By using RB mode, you can read binary file, where RB stands for read binary. And next one is RB plus mode. By using RB plus mode, you can read and as well as you can write binary file. Next one is WB mode, where WB stands for write binary. By using WB mode, you can write binary file. And next one is WB plus mode. By using WB plus mode, you can read and as well as you can write binary file. Next one is AB mode, where AB stands for append binary. Already there is some information in my binary file. Now if I want to add new information to binary file, then I need to use AB mode. By using AB mode, you can add data at the end of the file. For example, already there is some information in my file. Now if I want to add some more information at the end of the binary file, then I need to use AB mode. And last one is AB plus mode. By using AB plus mode, you can read and as well as you can append binary file. Normally how we create a file, like we will go to notepad in my system and then I will write some text in that notepad, then I will save that file with some name like file.txt. This is how we create files. But our topic is about how to create a file by using C programming. Now I will explain how to create a file and then how to add text to that file, and also I will explain how to close a file by using C programming. Normally we can store values in C programming like int a equal to 10. We can store value 10 in variable a. But now I want to store file in C programming. But in C programming we cannot store files. So here I can only store address of a file. In order to store address of a file, we need to use pointers, and we will create file by using file type. At first I need to write hash include stdio.h. After that write void main. In order to create a file, we need to use file type, file in capital letters. In order to create pointers, we need to use star. Star represent pointer variable. I am taking pointer variable name as a. After that write a equal to. We can create file by using fopen function, where fopen stands for file open. I already said before. By using fopen function, we can create new file. Already if there is file present in our system, then we can open that file. Now I want to create file in local disk E. So I am giving address local disk E and I am giving file name as my file myfile.txt, because I am creating text file now. So I written here .txt, where txt stands for text file, comma. I want to add some information to this file myfile.txt. So for that purpose I need to use mode, that is write mode. By using write mode, we can add any information to the file, semicolon. Whenever you write this line of code, then this fopen function will create myfile.txt text file in local disk E. Now I want to add some information to this file. So for that purpose, I need to use fprintf. By using fprintf, we can add information to the file. Open bracket. This file is present in address A. So I need to write here A, comma. You need to include double quotations, and whatever the text that you want to write, you need to write the text in double quotations. I want to add information like my name is Nagendra. Close double quotations, bracket, semicolon. Whenever you open fprintf function and you write some information, by using fprintf function, you can add information to the file. We can close this file by using fclose function. So write here fclose and write address here. Address is A and then close bracket. This is how we create a file. We add text to the file and then we close a file. Whenever you run this program, you do not get any output here. But whenever you run this program, you do not get any output. But it will create file in local disk E. After executing this program, you open computer and inside computer open local disk E. Whenever you open local disk E, you can see file. That file name is my file, because we given here file name my file. If you open this file, then you can see text, that is my name is Nagendra. This is how we create file by using C programming. This is another program in order to read a file. Read a file is nothing but whatever the text that is present inside my file, I can see this text in my output screen. This is example program. Here I written file star A, where star represent pointer variable A. After that I write A equal to fopen. By using fopen function, we can create new file and as well as we can open existing file. So now I want to open existing file. This file name is file.txt and this file contains information, that is my name is Nagendra. Now I want to open this file. So for that purpose I give an address that is E, local disk E, and file name is file.txt. I want to read this file, so for that purpose I need to use read mode. In order to see this file information on my output screen, at first I need to create one string variable, and then I need to store this file information in this string variable. After storing this file information in string variable, we can see output. So in order to store file information in string variable, I need to take one string, that is character, and I am giving variable name as b, and I am giving 50. Character data type along with arrays represent string. So now we created string and size of string is 50. That means I can store up to 50 characters. And now open while condition, while fscanf. By using fscanf, we can transfer file information from A to B. So here we need to write address A, comma, all these are strings. So we need to write here %s, comma B. By writing this, we can transfer file information, that is my name is Nagendra, from file A to B. Here I written %s because all these are string characters. So I want to transfer data from A to B until end of the file. I want to transfer data until last character. So for that purpose I need to write not equal to end of file. By using, whenever you write this end of file, this fscanf will transfer data from A to B until end of the file. Whenever you write this condition, then this character B will store file information. This file contains information, that is my name is Nagendra. So this character B will store information, that is my name is Nagendra. It will just store information. So in order to display this information, I need to use printf. So for that purpose I need to write printf, whatever the information that this character B stored. Now I want to display this information. So for that purpose I need to write printf %s, comma B. Printf %s, comma B. Whenever you write this statement, then you will get output as my name is Nagendra. Whatever the data that is present inside my file, I can see this data in my output screen. So output is my name is Nagendra. So at last we need to close file by using fclose function, fclose of A. This is program in order to read data from a file. Next topic is, if you want to place cursor at desired position, then you need to use random access file functions. Random access file functions are classified into three types. First one is rewind function, next one is fseek function, and last one is ftell function. For example, this is my file. My file contains text, that is engineering. Normally cursor will be at starting position, but if you want to place cursor at any desired position, then you need to use random access file functions. For example, I want to print last character, that is G as output. So for that purpose I need to place cursor to last position like this. If you want to place cursor at any desired position, then you need to use random access file functions. First I will explain rewind function with example program. By using rewind function, you can bring cursor to the beginning. That is, by using rewind function, you can place cursor to the starting position. For example, my file name is file.txt. My file contains text, that is college. Now I will write program in order to see this text information, that is college, on my output screen. At first I need to place file text in one string variable, and then I can see output by using printf. So at first I written file type, and then I took one pointer variable, and pointer variable name is A. After that I written A equal to fopen of file.txt. This file.txt is present in local disk E. So I given this address. So by using fopen function, I can open this file which is present in local disk E. Whatever the data that is present inside my file, I want to see this data in my output screen. So for that purpose I need to use read mode. Now we need one string variable in order to store our text information. My file contains this text, that is college. Now I need to store this information in one string variable. So for that purpose I written here character B. I given string name as B, and I given size as 50. Character along with arrays represent string. Now I need to transfer file data to variable B. For that purpose we need to use fscanf. By using fscanf, we can transfer text which is present in my file A to string B. So by writing this fscanf A comma %s comma B, whatever the data that is present in my file, the data is transferred to string B. I want to transfer this text until last character. Till last character I want to transfer. So for that purpose I took while loop, and I given condition as not equal to EOF, where EOF stand for end of file. By writing this line of code, my data is stored in string B. So now my string variable B contains text, that is college. Now this variable B contains information, that is college. Now whatever the data that is present inside my variable B, now I want to print this information. For that purpose I written here printf percentage s comma b. By writing this, I will get output as college. It will print first character and then it will print second character until not equal to end of file. That means until last character it will print output and my cursor will be at last position. Now I want to print this information again. Now I want to print this college again. So for that purpose again I return same 2 lines of code. Here again I return while loop and again I return printf. By writing this code again, I need to get output twice. I need to get output as college again. But I do not get output college again because already when I printed this file information for the first time, my cursor is placed at last position. So in order to print the same information again, I need to bring this cursor to first position. So when I bring my cursor to first position, then I will get output as college. So for that purpose, here we need to write rewind function, that is rewind. My file is present in pointer a. So we need to write here rewind a and semicolon. Whenever you write this rewind a, then your cursor will be placed at first position. So now you will get output as college. Now you will get output twice. First time it will print college and then again it will bring cursor to first position and then again you will get output as college. And at last we need to close this file by using fclose. So at last I return fclose of a. Next I will explain fseek and ftell with example program. At first I return file star a where star represent pointer variable a and I return a equal to fopen of my file is present in local disk E and my file name is sample.txt. So I return here E sample.txt. Now I want to read this file. So I return here read mode. I want to read only single character. So for that purpose I return here character B. I did not took string, I just took character because I want to read only single character. Next I return fseek. Fseek function will take 3 parameters. First one is file location. My file is present in A, in pointer A. So I return here A, comma. Next parameter is position. In which position you want to place your cursor? I want to place cursor at first position. So I return here 0. Fseek function starts with 0 where 0 represents first position. And third parameter is this fseek function contains 3 constants. First one is seek set. In order to place cursor from starting position, then you need to use seek set, and next one is seek current, and last one is seek end. I will explain these 3 with example. So at first I return here seek set, SEEK underscore SET. We need to write this in capital letters. Whenever I write this line of code, then my cursor is placed at first position. So my cursor will be at first position because I written here 0. After that I need to write here b equal to getc of a. That means I am placing single character to variable b. I am placing single character, that is h, to variable b. Whenever I write this, first character h is placed in variable b. Now this variable b contains character h. In order to print output, I need to write here printf int location %d. This %d is for ftell of a. I will explain what is use of this ftell of a. This %c is for character b. Character b contains value, that is h. So I will get output as in location 1 h. In location 1 h. This is output. This ftell function will say current location. Here my text is Hyderabad. So h is present in location 1, y in location 2, d in location 3, so on. For example, if I write here 1 in place of 0, then I will get output as in location 2 y. This is my output because here fseek function will start from 0 and whereas ftell function will start from 1. For example, in place of seek set, if I write here seek end and if I give here -1, whenever I write here seek end, then my cursor will be placed at last position. Now I want to print this last character, that is d. So for that purpose I need to write here -1. That means we are going back, so we need to write here -1. Whenever I write here a comma -1 comma seek end, then I will get output as in location 9. In location 9 value is d. This is my output. This is use of seek end. For example, if I write here -2, whenever I write here -2, then it will go 2 position backward. So I will get output as in location 8. In location 8 character is a. This is my output. For example, if I write here fseek a comma -3 comma seek end, at first it will place my cursor to last position and then it will move 3 positions backward, 1 2 3. So I will get output as in location 7 b. This is my output. And next I will explain what is use of seek current. Here I written fseek of a comma 1 comma seek current. That means From current position, it will move one step forward. So my current position is here because here I written -3 secant. So my position will be in place of B. So from B it will move one position forward. So now I will get output as in location 8A. This is my output. Definitely we need to include semicolon for this fseek function. At last we need to write here semicolon. And at last we need to close this file by using fclose function. This is example of fseek and ftell function.